In this video, we're just going to answer a question on determining the domain of a given function. So basically, if you're new to this topic, basically make sure you get to watch a video on the tag showing. Alright, so now find the domain of a function. That how do you get to do that? So basically, when you're talking about the domain, you're basically talking about the values of x that can define the function. Alright, so what are some of the values of x that we can plug in the function and help us get the results, which we call the range? Okay, so basically what we need to realize is we can distribute the square root that we have in such a case. Okay, so if you distribute the square root, what we're going to have is our function f of x is basically going to be equivalent to x plus 3, of course is the root of it, over what? Over the root of what? X squared minus 16. Okay, so what is important is when you have a fraction, let's say a over b, for this function to be defined, you want to make sure that basically your value of b, which is the denominator, should not be equivalent to what? To a 0. So I want to make sure that whatever value of x what we get to plug in on the denominator part should not be give us a 0 there. So what should we do, or what do we want? So we want to make sure that basically when you have x squared minus 16, of course we do have a square root there, this is not supposed to be equal to 0. We don't want that. Okay, so let's get to first of all determine the values of x that can make this function to be equal to 0. So of course, if you square both sides, you realize that you're going to remain with x squared minus 16 being equal to a 0. And in such a case, what do we have now? So we find that the two values of x that basically can make that part being equal to 0 is, of course, that is x squared is equal to 16. X is either equal to a positive 4 or a minus 4. So these are the two values that can make this function, which is part of a denominator, to be equal to a 0. So we don't want to have a 4 and a minus 4, because that will give us a 0. But now if we look at this function again, the other thing that we need to note is we want to make sure that basically the values that we have again under a square root should always be what? They should either be equal to a 0 or greater than a 0. So we want to look at the numerator now to see what we're going to have. Okay, so remember, for this function it is x squared minus 16. That is basically the one that we don't want the values of x to be equal to 4 or a minus 4, because we don't want the denominator to be equivalent to a 0. So let's now focus on the numerator. Okay, so when you have x plus 3, you want to make sure that for the function to be defined under a square root, the only values that are defined are basically values greater than or equal to a 0. So we want to make sure that whatever value of x that we get to put there should be greater than or equal to what? 0. Okay, so for the numerator, there is no problem when it is equivalent to a 0, so we can include that to be part of our solution set. So if you get to find the values of x where you're going to have, so the minimum value that we expect to have is what? A minus 3. That's the minimum value that we should have. Okay, so then going up, and we do expect that one should give us a 0. Okay, so now apart from that, if you look at the denominator as well, you want to make sure that the values that you're going to have as well should also be what? Should also be greater than what? They should all give us a value that is going to be greater than a 0. And if you get to do that again, of course what you're going to have are the two values, 4 and what? And the minus 4. So for you to solve that inequality, or to find the values that are going to define it, you can come up with a number line to say this is what you have. So the two values that are basically solutions to that function are, we have a minus 4 and a positive 4. So now you can get any value in between, of which 0 is the simplest. So if I get a 0 where I plug in that function, I'm going to have a minus 16, which is going to be undefined, because the root of a minus 16, we basically can't determine that, so we don't want that. What about if you try any value greater than 4? It's going to work. Okay, it's going to work because you're going to have a value greater than 16, implying that this side you're going to have a positive value as a result. So for example, if you try out 5 squared is 25 minus 16, which is going to give us a 9, which is going to be a defined value under a square root. if you get a negative 5 for example as well, since it is to the power 2, it is still going to be a positive value. So the solution set are basically going this side, and from this side going this side. So now notice something there. I'm basically using the set theory that you've basically done to simplify or make your work easier. Okay, so this function is a single function. So the result that we have basically should be able to satisfy the two equations. Okay, so this is what I'm saying. We have a minus 4 there, then we have a positive 4 there. So the values that can define the function that is on the bottom, of course we're excluding negative 4 and 4 because you'll make it to be equal to 0, which is going to make the function undefined. So I'm not going to shade inside there. But all the values greater than 4 and less than 4 and less than negative 4 are okay. They are able to satisfy the equation. That is for the bottom part. Going back to our numerator there, we've said x should be greater than or equal to negative 3. So negative 3, if you check our number line, is somewhere there. Okay, so we want values greater than that. So negative 3 is part of the solution set, so we can shade it, implying that if you put a negative 3 on top there, you're still going to do what? You're still going to have a defined function. So now this is going this side because we said greater than. Okay, so now which one is going to give us our domain? So if I get any value between negative 3 and 4, which can be maybe a 1, I plug it in the function. So we are going to see that on the denominator part, it is going to be undefined. So that's why we don't have anything for representing the bottom one. So what is going to make the function undefined? So I want to come up with a set of values of x that are satisfying both equations. And in such a case, it basically requires us to look at now the common range. The range that is part of both the function that is on top as well as on the denominator part. So basically where they are overlapping is basically this part. So that region basically gets to give us the domain. So now how do we get to do that? So it's going to be basically the intersection. Let's get to present that work now. We'll see what we're going to have. So the intersection of what? So this is a point where it is starting from. We're starting from 4. So notice that 4 is basically only part of the one on top, and the one down we've not shaded inside, implying that 4 is not part of the solution set. So we can say that we're starting from 4. 4 is not included. Then x should be less than what? So we are going up to infinity there. So these values are the ones basically that are going to make a function to be defined. If you get any values between that range, it's going to be satisfy the equation of a function that we have. So you can also present it using the set interval notation by saying you are from 4 all the way up to what? To infinity. Okay. So this is basically your domain. If you get values between 4 and positive infinity, they are going to satisfy the function. Okay, if you try any values outside that, for example, if you can try out a 2, you can see that it's basically going to undefine the function, because on the bottom part you're going to have 2 squared minus 16, which is going to be less than, or which is going to be a negative, which is undeterminable, because you can't determine the root of a negative number. Again, if you decide to get values basically maybe a 2 and try to, or maybe a negative number that is of course so less, you try to put it on the top for example a minus 4. A minus 4 plus 3 is also going to make that function undefined. So the only possible, or the range that, or the domain that we're interested in is from 4 going up. So basically this is how you get to find your domain. So thank you very much for taking time to watch the video. Make sure you check out some more videos, tutorials on domain and range. Thank you very much for watching.